In this video, I'm going to be continuing with the designing and building of the helicopter driveshaft, and I learned something that could mean what I've built so far is no good. In the last video, I made a part of the driveshaft which included a universal joint yoke. However, the size of the shaft had to be 20.08mm to press fit hardened steel collars. But the bearings need to slide over this shaft are stock size and 20mm. If you are a particularly determined person, you would no doubt enjoy the challenge of getting these two parts to fit together. A better way is to increase the size of the bearing by 0.08 of a millimeter. Bearings are hardened and cannot be increased in size by just a drill or even a tungsten carbide boring tool. They can be cut by use of a cylinder grinder, however I do not yet possess one of those tools. I have two options then. Either I spend some serious money on a cylinder grinder, or I just force my air tool to get better acquainted to my lathe. Never tried this before, but I don't see why it won't work. Obviously I don't want grinding dust to contaminate the bearing, so I've just smeared the bearing with grease. I'm very pleased with the results and it's quite easy to do. With that test fitted, I've noticed a problem. There is a misalignment between the engine and drive. We can see the drive is off to the left and it should of course be in line with the engine. It certainly used to be before the unscheduled rapid disassembly. I knew something had moved because the angle frame was attached to the tubes via pop rivets. The rivets sheared and now the holes don't align. It's bent from the impact, but straightening it will make the alignment worse. I'll loosen some bolts and see if the frame will move. It moves, but springs back into the same place. I'll keep removing parts and try and find the reason it's off. A comment in the last video got me thinking about a potential problem with using universal joints in my driveshaft. It revealed a hole in my knowledge about how they work. I think most of us know that universal joints are not constant velocity joints. This means when the joint is tilted at an angle, the rotation is not uniform. It causes a shaft connected to accelerate and decelerate every revolution. The solution to this is to have a joint at each end of the shaft and orientated so that the acceleration phase on the first joint is cancelled by a deceleration phase on the second joint. This is what's called universal joints in phase with each other. The shaft in between the two joints is still accelerating and decelerating, but the input and output shafts connected via the driveshaft are rotating at a constant velocity. This is only true if the joints are articulated at the same angle. If one is straight and one is angled, the rotational velocity will no longer be constant. And this is what I failed to realize when designing the new drive. In my case, I will have joints with different angles each end at certain times. So all that work I did making the first universal joint may be a waste of time. It all depends on what the limits are to universal joint misalignment. I found this formula online to calculate the percentage change in rotational velocity according to RPM and angle of the joint. 4 degrees is about the maximum difference between driveshaft angles. This is full rotor articulation and I haven't actually needed to use this much rotor tilt in the past. With 4 degrees, then the speed variation is 27 RPM. That's with the driveshaft spinning at 5,500 and a 0.49% change in rotational velocity. I must decide whether that much variation is acceptable or do I need to scrap the idea of universal joints. As mentioned, 4 degrees is absolute maximum and if reached would only be for a very brief period. If the angle was only 3 degrees, then the speed variation would only be 15 RPM, 2 degrees 8 RPM and 1 degree 2 RPM. So if the angles are low, it might not be a problem. There are other options though. When I found the Benson B9, I saw how the driveshaft was built. At that time, I believed the driveshaft flex joints were just rubber tyres. I decided at the time that it seemed a rather agricultural solution to the problem, but looking at it again now through different eyes, actually, it might have been pretty clever. Firstly, these tyre drive couplings are constant velocity. They allow a mechanically soft drive as it's rubber, and they can accommodate up to 4 degrees of articulation. So good so far. On the Benson B9 they were used to facilitate the drive angle but also the change in driveshaft length, I assume by flexing the tyre. Now I get a bit stuck with this type of coupling because I haven't found a tyre coupling that can accommodate the actual movement I need of at least 25mm. Nowhere near actually, and the RPM is also a problem, the maximum being 4,500. What then are these couplings that were used on the B9? Another option I have is to use what's called a double universal or cardan joint. A double cardan automatically cancels its non-uniform velocity and is considered constant velocity. I would probably only need that at the top, and I think this would work. Not something I really want because it adds weight, but it's a potential solution. Another joint to consider is the Thomson constant velocity joint. This is perhaps a more compact version of the double cardan joint. It can handle the speed and there's no problem with lubrication, friction or CV boots exploding. The Thomson company is Australian. I haven't found an English distributor yet for prices or info on the joint weight. Looks a complicated joint, so making my own lightweight version in aluminium looks too difficult. With all these difficulties, you might be wondering, why am I bothering? I do occasionally get asked why I do this sort of thing. Helicopters have been invented already, so what's the point? The only objective with my flying projects is to have fun. I'm not trying to invent anything new at this stage. It's just a hobby. Engineering used to be my profession, and it wasn't exciting, but I knew it could be. The point of sharing the adventure on social media is because I enjoy sharing it, and I hope it has some sort of benefit to the people that watch it. It has certainly benefited me by putting me in touch with people with expertise greater than mine. There are people out there doing similar things. I've had contact with them, and I have been amazed at what they have done. But you won't find anything about it online. I think it's a shame that they haven't shared the projects, but I understand the reasons for not doing so. As I've said, the prime reason for now is just fun, but who knows what it might lead to. For a lot of people there has to be some sort of bigger plan, a financial reward at the end for example. But for me there's no such plan. As long as I can afford to fund the projects I want to make, that's good enough for me. It would be nice, of course, to invent something new, and I might turn my attention to doing something like that in the future. But would that be as much fun as the helicopter? Chances are pretty slim.
You're pretty clear standing over here. Walk on a bit. This is just the other side of the hedge.